These are solutions to quiz 3. So in the first problem, we're doing a 5-number summary for our data, and the reason we use the 5-number summary is because it doesn't include a lot of computation with a calculator. So this is a very quick summary and graphical representation of data that we can do just by being able to write the data down in order, in increasing order. So if I take the data and I make a list, this is sometimes easier than trying to visualize the data from the stem and leaf plot. But this data represents quiz scores that are grades out of 100. So I'm just going to write them all down. And again, this is a version of the quiz that is probably not the version that you took. So you should look at the problem that you had on your quiz and then try to fix any errors that you have based on the way I'm doing the problem, not on the answer that I'm giving to the problem. So there's my data. If I count my points, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 7th one down, 1, 2, 3, 4, 5, 6, 7. The halfway point is right there. So I draw a line at the median. Again, that line might go through one of the values. There could be a value that's exactly the middle value. In this case, there's not, because there's 14 values. So if I draw a line there, that makes 7 above and 7 below. The median then is just the average of the two on either side of that. So the average of these two, so halfway in between these two numbers. Now in this particular data set, those two numbers are equal. So halfway between 81 and 81 is just 81. So my median is 81, but that could very well be a number that's not even in the data. It could be a number that's just halfway between those two data values. All right, so if you've done that right, then above the line and below the line should be an equal number of values. In this case, there's 7 above and 7 below. So with 7 numbers, that's odd, there is going to be an actual middle value. So the number right there, the 4th one, is the middle value among those 7, and then down here, 91 is the middle value among those 7. So those are my quartile scores. So the first quartile is 74, second quartile is 91. Obviously the minimum value is 51 and the maximum value is 97. So that's my 5-number summary. When I'm trying to draw a box and whisker plot or a box plot, what I want to do is have an axis with a scale. I should try to make my scale as even as I can. I don't want to make some 10 values be really wide and some be narrow. So try to make even tick marks. So all the values will fall between 50 and 100, so there's no reason to include more than that. And then I'm going to put a little dash mark at each of the numbers in my 5-number summary. So I put 1 at 51. I'm going to put a little mark above 74. Put another mark above 81. Another mark above 91. And then another mark above 97. So that gives me 5 marks. The outer part of that is going to be my whiskers, and the inner part of that is going to be my box. So you should see a vertical mark at each of the value in your 5-number summary, and then you're boxing it in. So that's what that's supposed to be one line. So that's what a box and whisker part looks like. There are 5 marks that you have to make the box and whiskers. Those are the 5 numbers in the 5-number summary. Okay, so given that, we can write a measurement of spread. That is the IQR. That's the interquartile range, so the difference between the third and the first quartile. So in this case, 91 minus 74 is 17. Now the outlier using the 1.5 IQR criterion, first of all we have to calculate 1.5 times the IQR. And I've closed my calculator, hang on. Oh, I guess I can do that. That's 25.5 in this case. And then the IQR criterion, the outlier criterion is, and this is the thing that I had messed up before, so this is the correct value. We can write down that normal values, and so I'm going to put that in quotes because normal, what is normal really? But the numbers that we're going to say are not outliers are between blah and blah. And these blahs they come from, the lower number comes from taking 25.5 below the first quartile, and the upper number comes from taking 23.5 above the third quartile. So that is adding and subtracting it to different numbers, which is different than what I told you in class, but this is the correct criterion. So if we look our numbers back up, Q1 is 74 from up above, so 74 minus 25.5 is 48.5, and Q3 is 91, so 91 plus 25.5 is 116.5. So that's the range of values that we expect, we would consider to be normal for this distribution, and so any number outside of that range we would consider a potential outlier. Well, the minimum value above is 51, and that is between these two values. That is between those two values. And so, no, we do not include, not an outlier, because it does fall between 48.5 and 116.5. Okay, the last question is about using the empirical rule. The empirical rule says things like this. It says a certain amount of the data falls within some number of standard deviations of the mean. So we need to make sure we understand what that means. It means that 95% of your data, so when it says within 2 standard deviations of the mean, that means the mean minus 2 standard deviations is the lower number, and the mean plus 2 standard deviations is the upper end of that statement. So within 2 standard deviations means anywhere between 2 standard deviations below up to 2 standard deviations above. We're given the mean and the standard deviation, so these are both easy calculations. Here this will be 65.3 minus twice 3.3. So if I do that on a calculator, 65.3 minus twice 3.3 is 58.7. So 58.7 inches is the lower end of that range, and 65.3 plus 2 times 3.3 is 71.9. So the statement that the empirical rule says that approximately 95% of all women have heights between 58.7 and 71.9 inches, that's exactly what the empirical rule says for this distribution. Remember, there were really 3 statements from the empirical rule. One told you what percentage of data fell within 1 standard deviation. This statement tells you what percentage of the data falls within 2 standard deviations. And there was a third statement that said what percentage of the data falls within 3 standard deviations. So those 3 statements together make up the empirical rule. And again, it only applies to what we call bell-shaped distributions.